bubble sort insertion, selection, merge, and quick, right? So I would like to show you how it's work. This will be easier for you to like review what it is and how it's work. Basically, we're gonna use the big O notation to measure the time complexity of an algorithm. So how we can measure the time complexity of the algorithm is depend on coding here. So as I showed you last time that if they have two for loop and then they will run for 2 rounds, maybe the big OS will be n square, something like that. For the bubble sort, and if we see for n square, is the quadratic equation, right? When the number of the data or the number of calculation is increased like up to 1 million, so you can see that numbers of the time that you have to calculate is will be increased as well, very fast comparing to this one. So it's depend on the equation, and you can see why constant is very low because it will keep as a constant. Then when you replace n here, log n, and you can see that when you use log, it will be a little bit slower. You can see slower that like start from 1, 2, 3, 4, and 10. And even is up to 1 million data still stick at 20 or ON, but N is like N equal to N, right? So when N equal to 1, output is 1, 2 is 2, 4 is 4, 8 is 8, and then with 1 million is equal to 1 million. So it didn't reduce the number of time. Okay, it's exactly the same number of time. Okay, another one is n log n square, and n cube. So you can see that how much they grow so fast. Okay, so this will be that explanation when we need to know about the big O versus for the worst case of the algorithm. The first one I'm gonna tell you is the bubble sort. So for the bubble sort, the idea is very simple, that we will try to search for the value that's smaller, and then we try to like swap the location by using temp. The idea is very simple, just like that. For scan and then swap. Okay, so let me show you this one. Here is when we start print A, right? The next step is we will try to compare like 6 and 5, and then we're checking that 6 and 5, which one is larger, which one is smaller. If it's true, mean that we need to swap. So it's mean that 6 and 5, we need to swap 6 and 5. Here it's changing. Okay, next step, 6 and 9, 6 is smaller than 9, then we don't have to swap. The condition here is false, then do nothing. The next step, right? And 9 and 3, 9 is larger than 3. So what we have to do is we have to swap 9 and 3, right? And then we swap 9 and 3 here. And the next one is checking 9 and 1. 9 is larger than 1. So condition is true, then we have to swap the number. So the result will be shown here. So as you observe, you can see for the next round, right? We chain I is minus minus, so it will reduce from 4 to 3. The next one is checking 5 and 6. 5 is lower than 6, do nothing, right? 6 and 3, 6 is larger than 3, so swap, right? 1 and 6, 6 and 1, and then swap to 1 and 6, right? And then the time is reduced to from 3 to 2 for the next round from I here, minus minus here. Then we will swap until we get the final solutions. So for the bubble, so if you observe, you can see that we try to fix the largest value on the right side, and then try to swap things in the front. That's why we can reduce the time computing for the first loop. Okay. The next one is selection sort. The selection sort is quite simple, but they also use two nested for loop. So when we talk about two nested for loop, maybe you will think about n square, right? The thing that they're gonna do is they try to find a minimum value on the list and then swap it to the first position. So the thing that different from the selection sort and bubble sort is Bubble, they try to sort the largest one to the right, but for the selection sort, they will try to move the minimum value to the left, okay, to the first position until the end. So you can see that here is the condition for swap, and this is like checking the condition that we're gonna change the index to the pointer index or not. Okay, so this is the way how we can okay, let's see here. So the first position, we're gonna start with the index I, and then try to find a minimum value that is this the minimum value in the list or not. Okay, and then in the end, we try to swap the value to the first position by getting temp and index will be like the smallest value. And then we'll keep repeating until everything is sorted. Okay, let's see the example. The first one for the first round, when the index is equal to zeros and j is equal to 1, right? You can see here, j is start from I plus 1, so j is equal to 1. So this will be 6 and 5. Okay, we check 6 and 5. That's 6 and 5. Which one is larger or smaller? And then 5 and 9. And 5 and 3. 3 is smaller than 5. So what they're going to do is checking 3 and 1. Okay. And then what they're going to do is they're going to find the smallest value, right? Checking, okay, one more round. We check 6 and 5, right? The first one, 6 and 5. 5 is the smallest. So 5 and 9, 5 still the smallest. 5 and 3, 3 is the smallest. And 3 and 1, 1 is the smallest. So we get the smallest is 1. Then move 1 to the first position. That's it. Okay, the next round doing the same thing. 5 and 9, 5 is the smallest. 5 and 3, 3 is the smallest. 3 and 6, 3 is the smallest. So right now we move 3 to the next position, which is the second position here. Same thing, keep repeating the same process. 5 and 9, 5 is the smallest. Keep 5. 5 and 6, 5 is the smallest. Then move 5. Move 5, replace 9 here. The next step is 9 and 6. 6 is the smallest. Then 6 replace 9. And all of this thing is already sorted. All right. The next one is insertion sort. Insertion sort is tied to like move the position. Okay, here you can like keep repeating and checking the condition here once again, but let's see how it's worked first. Okay, what they're gonna do is they're gonna use while loop. This will like start from for loop for the length, and they're gonna use the condition, true and false condition, and use while loop. And again, you can see that inside the while loop, they're gonna check if else condition that AJ is larger than the value that we set or not, and if is found. So the while condition is showing that not found, right? But once it found, then they will return true. Okay. So they're gonna checking the condition. So if this condition is true, then it means that we need to do something inside, right? Okay, let's see. 6 and 5, and then checking that 6 is larger than 5 or not. If 6 is larger than 5, then we will swap the value, right? When this two condition is true. And then the next one is the value of j when j supposed to be larger or equal to 0. But once we go to j minus minus, which is I minus 1, then this condition is false, then we go to the next step. The next one is will be I plus plus, right? So I plus plus I from 1 is increased to be 2. And then we're gonna check this condition again that is still not found, and then j is larger or equal to 2 or equal to 0. And then we're gonna check 6 and 9. 6 and 9, 6 is larger than 9, no, right? So we didn't do anything. And then they will fail. They will go to another condition, which is found it will equal to true. Just mean that it's already in order, like 6 is smaller than 9. Okay, and the next thing, go to the next round, which go to I plus plus. So I will increase from 2 to 3. So when it's increased from 2 to 3, they check the condition again, and 9 is larger than 3 or not. If I is larger than 3, it means that 3 is in the wrong position. So we're supposed to change the value of 3 here and then print out 3 here. Okay. And it will keep repeating. Keep swap the value, like compare 6 and 3. 6 is larger than 3, then swap 6 and 3, right? And then swap 3 is smaller than 5, then swap 3 and 5. All right. Boop. And then the value in front is already sorted. The next round is increase the I value from 3 to 4, right? Once it's already complete, then I is increased to 4. When it's increased to 4, then we do the same thing. We're going to check the loop inside that is smaller or larger. 1 is smaller than 9, and move 1. 1 is smaller than 6, and move 1 again in front of 6. 1 is smaller than 5, then move again in front of 5, right? 1 is smaller than 3, again, move in front of 3 until the end is already sorted. So this will be how it's worked for the insertion slide. You can see how it's worked like this. All right. So here is how they calculate the number of iterations. So it will be n squared. Okay. We also think about the best case and worst case as well. So we can see that for the insertion slot, somehow we can find the best case as well if the order is easy to sort. So the best case of the insertion slot might be just OM, okay? If we don't have to loop inside. So this will be just one round. No need to keep repeating in the if else. When the order is easy to sort, as you can see that everything here is almost sorted, just one value, right? Some see. Oh, okay, no. Everything is already sorted. 8 and 21, 32, 34, 50. So yeah, when everything is already sorted, then no need to do anything. We need to loop anything, right? And for the worst case, it's going to be like n square for sure, because we have to loop and then keep sorting something inside until the smallest one is moved to the front here. We'll make n square. The first layer n here, the second layer n is here. All right. Merge. So this one will be the case of the divide and conquer. This will be n log n, which will show the worst case of it. Okay. For the worst case, the concept of this one is quite simple, that we just put the pointer and then we compare the pointer together, like but here is we already split and we already sorted, but be careful for the merge sort. When we have the array list, we have to cut by half and then split it and then sort it using the recursive and then merge it back together. So this is the process when we try to merge things back together. So we compare the pointer A and pointer B, which one is smaller than each other, and then we'll put in the final result like this. So it will be like how A and B is combined together to get C. Okay. So this will be represent the condition of the divide and conquer. Like this. We split, we solve, and then we merge it back together.